I know I haven't made any videos in quite a while, and I was starting to make this video on work holding, fixturing, distortion of the materials and the materials themselves having stresses in them distorting the machine work. And it's really too big of a subject to show in one video, I feel like, so I might need to make multiple videos of this and maybe take out certain areas, I mean, like examples, I guess I'd call them, that are of just one way you can have problems, and then maybe we'll do another video on another way and things like that, because it's really too complicated. I started, and I'll show you the clip I filmed here, starting to think about this subject, and you know, towards the middle end of the clip I was making it, I was like, no, it's too much to show and explain. It's too complicated to show in one video, and I don't want to go to the trouble of making a whole bunch of videos if this kind of subject is not of too much interest to people. You know, I think it should be, because without taking these things into you know, into account, you're going to have problems with your machine work, particularly if you're trying to do this for a living. If you're, you know, if you're just a hobbyist and you screw up a part, well, you can make adjustments and make it again, and it's not that big a deal. But if you're working, doing a living in this profession, no employer is going to tolerate you screwing up too many parts. You know, you can't do that. So anyway, I was starting to edit this, and I'm looking at it, and it's like already like 30 something minutes long or something, the video, the one clip I took. And I don't make any kind of scripts or anything on videos, and I don't take a lot of care in the photography of these kind of videos, because it's just like, they're just information videos, you know, and there's not some real cool looking views and everything. But so I might, you know, I've had people complain, oh, you repeat the same things, and yeah, you know, if you don't know what you said 20 minutes ago, you might repeat it. So, you know, I'm not going to make too many excuses for that kind of stuff, but it happens. And I just want to make videos that are useful to people, and they can actually learn something that they might apply to their work. You know, like the last little video I made was on a little trigonometry example, and people seem to appreciate that and were receptive to that kind of stuff. And these kind of videos are going to be kind of similar things. You know, they're not going to be showing too well. The examples might show machine work. I think I might try to do that and show what happens, and maybe I could even record it, you know, on the video, what's happening as it happens. I don't know. That might be a little tricky, but maybe I can do that. So we'll see. So anyway, I'm going to show you this clip I took. And like I say, unscripted, I'm just babbling on about stuff and showing sketches on a notepad of what I've experienced in the past. And many of these things I learned the hard way. I screwed up parts doing it and found out, oh, I can't do it that way over the years. And I thought maybe I could help you not to make the same mistakes I did in the past, and learn from what I learned by just showing you different examples and what happens. I've noticed in a lot of YouTube videos, you know, the way people are doing things, and I'm looking at it and I'm saying, he's going to have a problem later on with the way he's going about that. But, you know, I don't like to be too critical on people's videos, because anybody that makes videos doesn't like that. You know, even if I read comments and people are like, well, you don't know what the F you're doing and all that, it's like, well, yeah, maybe sometimes, but it just gets kind of annoying. So I don't make comments trying to correct people and everything. You know, it's just kind of annoying when you read comments like that on your videos, I have to admit. But maybe I could make some videos showing what the techniques I've learned, and they're not the, you know, set in stone techniques. It's just stuff that I've learned over the years and have worked for me, and they might help somebody else. So watch the next clip that I took here. It's a little bit of a longish video. You might be interested. Let me know in the comments, you know, if you're really interested in this kind of stuff. I think you should be, like I said before, because this is where most of the mistakes in machining happen, is in this kind of stuff, manual machining or CNC machining. So look at the next clip and then let me know in the comments what you think. Thanks. All right, I got a question in a comment on one of my old videos, and the guy was basically asking, you know, you carefully line something up in the chuck or the vise or something like that, and then when you're machining it, doesn't the part move, or can it, or wouldn't the machining itself put enough force on it to move the part into fixturing, or the vise or the chuck or whatever you're holding it with? And obviously that, yes, that can happen. And you kind of got to go with your experience with the fixturing you're using and past experience in machining. But I see a lot of videos on YouTube, and these guys are holding the parts, and I'm not sure they understand how much the actual holding device they're using is putting distortion in the part itself. And I thought this, and I got to thinking about this subject, and I think this might be a kind of a good subject for a video, or even a series of videos maybe, on how best to hold parts. Over the years of machining, I've learned these things pretty much by trial and error, by actually scrapping parts because I was doing things the wrong way. And I see a lot of times, I see this happening on videos on YouTube in various ways when they're showing their machine work and stuff, and there can be a lot of things that cause this. Let's look at a vise. I've made videos in the past about this subject, in some older videos on my channel, about vices and distortion in clamping and how they distort the vise, the table, the machine, even the part and everything. But let's just go over it a little bit again. I'll just draw on we've got like vice jaws, and then we got the, we'll just consider this you know, a normal Kurt type of, or that type of vise. You know, there's many different brands now of these things. Back in the day when I was first starting machining, these vices didn't exist, and you were dealing with you know, Bridgeport style of vices, and you had a lot more distortion in the jaws and everything. These vices are a lot better. They tend to pull the part down because of the nature of the way they're made, and it pulls this moving jaw down. You know, if this was the, of course, the moving jaw on the vise. But what you have to consider when you're clamping on a part, and I see in many videos, these guys, they clamp, you know, they put these two parallels in the vise like this, and then they're clamping, you know, right on the very end of the part. And this is fine, you know, this is a way you do a lot of CNC machine work, because you want to go around as much of the part as possible, and there's nothing wrong with this. But you can be putting distortion in the part itself, clamping like this, because the vise bends, the whole vise bends like this. You know, if I was to exaggerate that, the whole vise is bending like this because the pressure is way up here, and the screw and everything pushing is down here, and the vise, it's just flexing the whole vise. And in very extreme cases, this can flex the whole table of the machine. I've seen this happen. If you have a whole line of vices, like you have 6 or 8 vices down a long stroke machine, and you tighten all those vices up real tight, you can actually bend the table and put the ways in a bind on the machine, and then this causes distortions in the machining because of you know, causing force on the lead screw and everything else in the machine itself. So there's a number of different ways that this can cause distortion. Now, one way to reduce this is to machine little dovetails in the bottom of the part here, and then put soft jaws in your vise and machine the mating dovetails, and you don't have to grab the part so tight and tighten it down so tight because it's not coming out of the vise jaws. That's one way. There's these new kinds of jaws that have these little gripper pieces on top of there that dig into the stock, and that's another way to do it too, if you can afford to do that. That would be a good thing to do, possibly. Now, if you're, let's look at a different situation. You got your same vise, but you have it opened quite a bit, like this. You know, here's the body of the vise, and the moving jaws way back wide open, and you're putting a thin piece of a material in here like this. Wow, my light just went freaky there. And you're grabbing on the part, and you got these parallels out here to hold the part parallel in the jaws, that, you know, this direction, but you're tightening down this, and what this has a tendency to do is to flex the part, I'll exaggerate it, up like this. So your part is really looking like this in the vise, and when you try to face the top off of it, and then you release the vise, it springs back down to where it naturally set, and you have a hollow in the part like this. So in cases like this, a lot of times what I've done in the past is I might want to tighten the vise up pretty tight to do some heavier machining, but not so tight that I distort it out of my ability to clean it up on my finish cuts, if that makes sense. And then I'll actually loosen the vise and then just snug it down just enough to hold it for my finish cuts. That's one way to get around this. Another way is to try to hold the part in the middle of the part here, or if I'm making sense here. In other words, you're putting the force down the center line of the stock and not just down on the bottom edge. If that's possible, sometimes that's not possible, of course, but if that's possible to do, and that tends to hold the part evenly, or even try to put the force on the top of the part with the jaws by putting the part further down in the vise. And if that tends to push the part down, you can put some more parallels underneath it here, and pushes down against the parallels. But even so, any way you do this, you're putting stress in the part with the holding fixture itself, and you need to take all these things into account. Now, not only does the holding fixture, or the vise in this case, put stress into the part, but the actual machining can put stress into the part and bend it in different directions. Let's take the case. Let me just of facing off a flat piece of stock, and you might have this either glued or stuck down with double-sided tape or something, or with toe clamps down to the table, and then you machine it. You face it off with your face mill or whatever you're using, and then the part bows up when you release it, or it bows up into the cutter even. I've had this happen as well, where you're machining along, and then the end mill or face mill or something starts to cut deeper out in the middle of the part, and you're saying, yeah, what's going on here? Well, you're actually pushing metal into the piece, and you're expanding the surface of the material. And this expansion, well, let me go back to a certain thing. When you have a piece of material that's made in, you know, like in the mill or something, they roll it or however they make it, and this distortion could be worse with a cold rolled material, because they roll it in the cold state, and it actually compresses the very surface of the material, you know, just a thin area along the surface here of the material. And then when you machine into that, you relieve that stress, and this pushes up, because this is pushing outward. If you can imagine this stress pushing outward this way in this raw piece of stock, and then on both sides, but it's sort of in balance before you cut into it. And then the minute you start cutting away some of this, it tends to relieve this outward force in the material, and this bottom piece will bend the material up this way. Well, you're kind of doing the opposite when you're actually machining. Say you have your face mill here, you know, going across this somehow, and this is more exaggerated the more negative rake the tool gets that you're using, as far as if you're using carbide inserted tools. And to magnify this real big, let's just say this is the surface of material, and the insert's a negative rake insert, so it's cutting a shaving off like this off of this stock, however it is, if I could draw a straight line, and it's actually pushing some of the material back into the material itself, because tools don't cut perfect, and so they actually force some of the the force back into the material. Well, this expands the surface again of this, so it'll do the opposite, and it'll bow the work up into the cutter. Well, a lot of times you have a good hold of it in multiple vices, like if this is a long piece, you might have that situation, and the minute you machine down the part, it looks straight, you release it in it, and all of a sudden it pops up in the vices, and then you have to straighten it. And this can be even more exaggerated with hot rolled material, because there's much more stress, cold rolled material, because there's much more stress in the surfaces of the material due to the manufacturing of the rollers forcing it in a cold state, so that it actually compresses the surfaces of the material. And you can see this. I don't know if any of you have ever sandblasted a piece of sheet metal, and so you put the sheet metal in your blasting cabinet and you blast it, and the metal bows up towards the side you're blasting, because you're expanding the surface of the material. And even though sheet metal is quite thin, it's enough to bow it up into the nozzle, actually, if you get carried away with how heavy you blast it on there. It's the same principle. You're pushing the material into the stock with your insert. This being a negative rake insert like this will even exaggerate this, because it tends to push the material. No carbide tool, or any tool for that matter, cuts perfectly. Some of the material is being forced back into the workpiece, and some of it's being cut away. Now the more positive rake, the more sharper the tool. That's high-speed steel tools. You can make them a lot sharper, but you can't machine as fast, because if the edge gets too hot, you lose your cutting edge. Whereas carbide, it can get hotter, and in reality, with carbide, you want the material to get hot in some instances, because you want to machine it away at a lower strength, if that makes sense. Like if you're doing like blacksmithing or something, you get metal, red or yellow hot, you can actually cut it with a steel tool, just hammer it into it. And the same principle applies to machining in some ways, is that the hotter you can get the material, the easier it is to cut off, but then your cutting tool has to withstand the heat. So that's why ceramic tools can cut off material at red hot state, or CBN tools, ceramic tools, because they can withstand the higher heat that's required to do that, and they just literally peel it off at a lower strength. At the higher temperatures, it's easier to cut it away. So this kind of machining works with materials that are difficult to machine sometimes, like Inconel and things like that, or high nickel content materials, assuming that the heat itself doesn't damage the work material itself. You can't do certain things sometimes, but that heat can also cause tremendous amount of distortion in the machining, or it can heat the part up and expand it. And I've had this case where I was doing, turn this over, it was in a horizontal mill, so I was doing this vertically, and I was roughing off a pocket in the center of the part, and then I went to drill some holes down the part, and I didn't think about it at the time, I guess, and this roughing raised the temperature of the part to such a degree that I started drilling my holes, and the part was warm or even hot when I started, but the coolant from the drilling cycle, because you run ceramic tools dry, I should mention that. You generally don't put coolant on a ceramic tool, because it'll immediately fracture the inserts and it won't work. So you run it dry, but then you come in here and you start doing other machine work, and you're running coolant on the tools, and it's cooling the workpiece down. And in this case, the holes got closer together as I went down the part. This part was about 18 inches long, or tall, and the hole spacing was out of tolerance on the, as I went around. This was it had holes all the way around the perimeter of the part, and so I ended up having to rough this out and then run the machine, just kind of playing the coolant on the part for maybe, I think it was like 5 or 10 minutes, just to cool the part down, and then come back and do my holes afterwards, which unfortunately I learned by scrapping one part to begin with to find this out. So all of these things can cause distortion in your work, and you have to kind of think about this. And like I said, with time, and experience, you kind of learn these things, and you kind of say, oh, you look at the part in the machine work and you say, oh, I know I'm going to get this distortion in the part. Now immediately you look at the material and you know, like I say, hot rolled material will tend to give you less distortion as you machine it than cold rolled material. Like if you take a 1018 cold rolled steel, this material is notorious for distorting when you cut into it. So one way to reduce that is to machine away some of the surface, or buy stock that's larger than you need maybe, and machine away the surfaces of the material before you actually cut your part out of it. That seems kind of intensive labor wise, but sometimes that's necessary. I've had the case where I had a bar of 1018 and I had to cut, you know, these notches in it like this down the length of it. This part was maybe about 2 feet long, and I had to cut many notches like this, and relieving this stress in the surface of the part right here caused this to bow the part up like this, because this has the original cold rolled compression, if you will, in it, and you've relieved it by cutting into it here, and it bows the part. Generally it'll bow it this way, you know, it'll tend to curve it like this if you do this kind of situation. And sometimes you don't know this until, you know, you're holding it with multiple vices maybe, and then you release the clamping force in the vices and everything pops out of the vise. You know, many of you probably experienced this in your machine work. So there's that situation. This can happen on a turn part as well. If you're turning, you know, the part, you can distort it or relieve stress in the bar that existed in there, and the part bows and it runs out. And you know, I've showed this in many videos on my channel as well, where you have to kind of rough the part completely, and then maybe even rough all the parts, and sometimes even let them set a little bit. Sometimes the stress takes a little bit to relieve out of the material, like in Inconels and stuff. This is particularly noticeable. We made a part that was I think it was about 46 inches long, and it was pretty narrow, but you know, in length, and it had all of these notches in it that were, you know, a certain way, and then the cross section of the part kind of looked like this too. And these, well, I've drawn them on the wrong side, but these notches were actually radius notches into the part this way. And we would machine, straighten, and then we'd send these to the customer, and they'd say the parts aren't flat, and they'd send them back, and sure enough they're not, because they set out in their hot warehouse and the parts distorted. You know, many weeks later they'd send them back rejecting them. And this kind of thing can happen, just the stress relieving over a period of time even. So that stresses in material, but you can also put stresses in the part holding it the way you do, or the way you're holding it, if you will. You know, that'll even on a lathe, say you got a lathe here and you got your chuck jaws holding this part. Let's say the part is you know, a tubular part, and you're holding on to it, and you're boring into it, and you're making it to, or even if it was tube to start with, and then you release your jaws, and the part gets bigger in diameter, or it changes shape out here. It turns maybe into a, if you're 3-jaw chuck, maybe into a kind of like a triangular type of shape, or something like that, you know, because the jaws are pushing in. Then you let go of the part, and the part springs out where the jaws were, and it kind of collapses in between the jaws. That kind of thing can happen. Or I've had this happen where I was machining a part out of tube, and unfortunately the guy that supplied this material to me drilled and honed, had a drilling place drill and hone this tube. This tube was long, but it had a smaller hole in the end, and it opened up to a bigger bore all the way down the tube like this. And so this was the tube here, and I had to come in and I had to mill some slots in the end of it, and that wasn't really a problem. But when I saw the part, I told the customer, I said, man, this is going to be a problem, I can tell you right now, because there was kind of a big long keyway machined in one side of the part all the way down the length of it, and then there was a little bit of a narrower one on this side. And the honing was done and finished to like 1/1000th of an inch tolerance. And I said, when I cut those keyways all the way down the length of this part, this was I think this material was like a non-mag stainless steel material of some sort too, which even made it worse. That's sort of like a 300 series stainless steel, similar to that. And of course, when I cut these in there, the whole tube distorted this way. It grew this way and shrunk this way, and it distorted the bores out of tolerance, which with much difficulty we straightened them out on a press by squeezing it back down, and then we actually had to rebore the bores because the whole thing actually shrunk in size, believe it or not. And then this can happen also too. You do stuff and then things change in size. I've had this happen particularly with big forgings of aluminum, and the part actually shrinks or grows in size when you start taking material off of it. So there's all these kinds of distortions that could happen due to the way you machine it, the way you hold the part, and everything. And I kind of see these videos on YouTube where these guys just stick the part in the vise and start machining it, or things like that. And sometimes you can do that with little small parts, or things like that. But when you start dealing with larger pieces of material, you run into these distortions, or even small pieces if they have close tolerances. Like you got to hold something perpendicular within 1/1000th of an inch along. The part might be 2 inches by 4 inches long here, something like a small angle like plate thing or something. And when you start machining away stock and you're getting out away from the bulk of the material, you get this distortion to it, and you got to take all this into account. It's kind of hard to tell you right off the bat, this is going to happen, exactly what's going to happen, because it varies almost every time you do machining jobs. But there is kind of general ideas that you can get. Like I said, when I saw this part, I told them, because this part was about I don't remember, it was about 6 or 7 inches in diameter. It was pretty big, and the wall was maybe a 1/2 inch thick here down the length of it, and the part itself was, I'm going to guess because it's been a long time ago, but I think it was maybe about 4 or 5 feet long total. And I said to him, I said, man, this is going to distort, and it's going to be a real problem. And there's already all this expensive material and the drilling and honing and everything of this, and sure enough, that's exactly what happened. We had to fight to save those parts, because the material, and it really wouldn't have been a problem per se if we had roughed in the OD and these notches, these keys, and maybe left a little cleanup stock, then come back and finish bore, or even rough bore and honed it the way they did it to begin with. Although on the bigger Mazak over here, they got this big heavy metal bar that's in the tailstock, and it's a 1,000 millimeter reach on the bar, so we could go up in here and hone, bore up in here far enough to get the bores. Maybe the parts weren't that long. Maybe they're only about 3 or 4 feet long. I can't remember, but the bar was long enough anyway to get up in there and bore the whole ID. In this case, it's a 100 millimeter diameter bar, and it's 1,000 millimeters long, heavy metal bar. And that was able to, on the steady rest out here, to save the part. We had to make a kind of a supporting ring thing out here. Here's another thing you have to do sometimes, that had screws that we could kind of snug onto the OD of the part, and the roller steady rest could run on the OD of this ring thing out here to bore it, because that part didn't have a big enough spindle. The machine doesn't have a big enough spindle bore to hold the part, and in reality you couldn't hold it that way anyway, even if it did, because there again, if you chuck onto something out here in the middle, or even if you had dual chucks on both ends of the spindle, you put distortions in the part, and then when you release it from the chucks, you're back to being out of round and everything. This can be a real difficult situation with some parts, this kind of stuff, because your fixturing is putting stress into the parts, and you know, and the material is relieving stress, and it's kind of a balancing act you're dealing with machine work here. And it's kind of like you gain knowledge with experience on what's going to happen to some degree, but you can never perfectly guess what's going to happen. This is the thing about quoting jobs like this too. It's kind of like, is it going to have problems? Is it not? And it depends on the material. Like certain materials distort more than other materials. Like this cold rolled 1018 or 17.4 pH is particularly bad for distortion when you're machining into bars. We've found, and to some degree, some Inconels. Aluminum forgings can be, you know, big huge blocks that are forged, and because they're compressing the material, and then when you take the surfaces off, it distorts. Stuff like that. Certain 300 series stainless as well. This particular, I can't remember the specification on this material. I just remember it as being this non-mag stuff. I can't remember. I think it's P550, something like that. It's what it's called. So these kinds of materials can have a lot of stress in them from the manufacturing of the material. And once you start cutting into it, you relieve it, and cutting long key slots down the length of bars distorts them a lot of times. I think what's the guy that with Turn Right Machine, Keith Fenner, he has a series of videos of how he straightens big shafts by just heating up a little spot on the shaft and quenching it with water. And you know, if you have this shaft, he has these roller things, and he puts it between rollers with dial indicator, and when he gets the high spot, he heats up just like a ½ inch of a diameter spot and throws water on it, and this will shrink, and it'll actually bend a big huge shaft down, you know, because it's shrinking and pulling the material in. And this is another thing that you have to do a lot in machining these type of parts. You have to straighten them in between operations a lot of times as well. And straightening materials in hydraulic presses is a whole science unto itself. It's really, some people can do it and some people just flat can't do it, because it requires a certain feel for the job and how you're doing it and everything. This is kind of a, I don't know, this is kind of a lengthy subject that could go into a lot of long detail on how to do certain things, and maybe it'd be better to focus on one specific thing and show the distortions you get with it, and how to work with them. I don't know. See, now that I'm starting to talk about it, I can think of so many different ways and things that could happen that maybe I could. It's not possible to explain this in one video. And it might be better to do actual demonstrations on this subject. I don't know, if you think that if this is an interest to you, you know, it has to be of interest to people that do machine work, because this happens to you all the time, and you end up machining the part and you find, oh man, the part didn't lay flat, now I have to straighten it, or something else, you know, my cutting tool gouged into the part because the part warped up into the tool, things like that. Maybe I should find out, you know, maybe I should just make this short video and ask, you know, would this kind of a subject, I would think it would be, but it would be of interest. It's kind of like, in a way, maybe I could make up setups on the machine and demonstrate various ways that you can distort the part with the work holding techniques, and or the material has stress in it and it distorts, or the way you machine it and it distorts the material because of the type of tooling you're using and things like that, and what might be better ways depending on the tolerances you're trying to hold and things like that. So maybe I should just make this sort of a little bit of an introductory type of video where I can ask you, would this be something that would be an interest for me to show in more detail? Because this kind of a thing, this is where people new to machine work generally make most of their mistakes, even if they got the machining dimensionally correct, but then things went out of whack on them because of these kind of situations. They're work holding the material, the tooling they're using. So I think I'm going to wrap up this video right here and ask everybody the question, would this be interesting for me to make more detailed videos on? And if so, then I could put the effort into doing it, because special setups and everything would take a long time to do and explain and show what's happening. And particularly with vices, you can distort things a lot with a vice because of the force you're putting in on clamping it, and the way your jaws are machined, if you're using soft jaws, or even your hard jaws and parallels, and the way people hold the parts in the vise to square them up. You know, I've seen a lot of videos on this, you know, where they have their jaws, like this. I'm just going to draw the jaws, and you know, they put, you know, a half ball in here, and they're holding the part up against the jaws, and they're doing, although this is a better way to square the part than just holding it in raw jaws maybe, but you can actually not end up with a square part doing it this way, even because of the force you're putting clamping the part, because naturally it takes a little more force to clamp it when you're only holding it with the point of a ball. And so you're tightening the vise, you're embedding that ball into the stock usually, and you're distorting the whole vise. And so when you take it out and you machine the other side and you check it and you say, oh, it's not really square. Well, there's reasons for this, that over a long period of time doing machine work you learn by experience, but I've seen a lot of people show this, and this is better. Or they put a little rod here, you know, and they clamp the part like a piece of soft material like aluminum or copper or something. And although this is better, it's still, you can end up with distortion in the part. Or in particular, that one thing that annoys me with a lot of people is they have this part and they clamp it off to one side in their vise like this. If they're machining on the side of the part, I could kind of understand that, you know, like they're taking an end mill down the side. But if they're not doing that, put the part in the center of the vise. You know, if you're not needing that clearance for your tools or something, put the part in the center of the vise. Don't put it out here on the edges, because this racks, and even on the tightest of Kurt vices or any kind of vise, this racks the jaw, and you're only holding on to a point contact here, and you can pull the part out of the vise much easier when you're holding it like this. You know, these kind of things. Or if you have to hold it out here, put something else the same width over here on the other side of the jaws to balance the force on the vise. You know, I see this, people do this all the time. And for light machining, or maybe just drilling a little hole or something, this probably be fine. But even still, it's gonna, if you push on the vise here, this is going to tend to rack the part in the vise. And so if you got a close tolerance on your hole, it's going to be out of location because of doing this, where if you put it in the middle, you would be, you know, a lot safer to do it that way. Or put a balancing force out here of some sort on the jaws. So these kind of things, you know, I see people doing these things all the time in their videos. Another thing that tends to annoy me, not that I want to get on a big rant, is not cleaning your vice jaws out. I see all this shavings and stuff in the jaw, and they're just flipping the part and putting it back in. You can't do any kind of precision work, machining work, unless you clean the actual area where the part's being clamped. You don't have to worry about anything else in the machine to speak of, really, but you got to clean the areas where you're clamping the part on, the vice jaws, the chuck jaws, whatever it is. You can't have shavings in there unless you like dented up parts or something like that. But in general, to do machine work, you should clean everything very clean before you clamp the part in there. That's another thing that kind of irritates me a little bit watching people's videos. They have these nice close-up views with the camera, and then they have these shavings in there, and they just clamp the part on top of the shavings, you know. Again, anyway, these are some ideas we can discuss if this is of interest to people in some future videos, so that we can see what's really happening, and maybe I can demonstrate it with dial indicators on the part or the vise or something. I have in past videos showed this a little bit a long time ago on a vise in particular, how much distortion you can get clamping parts off center or clamping them high in the jaws, which like I say, sometimes it's unavoidable, you have to do that, but there's ways to reduce this amount of stress when you do things like this. So let me know in the comments, and thanks for watching.